So before talking about the easiest way to free engine game, I will talk about my self-introduction and what is free engine game and what is autonomous world. So my name is Shora, Shora on X or Twitter, and I'm working on PixeLAW as a co-founder. We won first prize from Starknet at the ESA Global Paris Hackathon last year, and we keep building. Also, recently I'm helping a trivia tech, which is casual pre-launching games. And individually, I wrote some articles like the 4 reasons we must pay attention to autonomous world and the survey of the definition of autonomous world. So, what is free-launching game? I think the definition of free-launching game is really simple. That is a type of Web3 games that have everything on chain apart from the front ends. So we have everything except for we have everything on chain except for front end. The famous examples are Dark Forest and OPCraft, I think. And I really like OPCraft example. This is a free on-chain version of Minecraft. So then what is autonomous world? In my opinion, the autonomous world is currently undefined, but there are some statements about what is autonomous world. So let me introduce a quote from Rudens from Zero Spark. So autonomous worlds have hard diegetic boundaries, formalized introduction rules, and no need for privileged individuals to keep the world alive. So basically, autonomous world is a kind of free engine game, but so if builders deploy a smart contract about their game, the game logics will keep moving and which executes the logics and they treat states automatically and forever. So it's a kind of world. So that's because we call our free engine game as our autonomous world. So it is a little bit different, but it's our kind of free engine game. But there are some controversy about the definition of autonomous world. So that's why I conducted the survey about the definition of autonomous world. So this is a graph about the percentage of yes response for do you consider this project as autonomous world? So as a result, Ethereum is the most closest project to autonomous world, and root is about 38% people. And the interesting point is free on-chain poker is not autonomous world. Free on-chain poker game is obviously free on-chain game, but no one considers it as autonomous world. So I asked the reason about this. So we cannot. So currently we have no definition about the autonomous world, but we have some major properties to distinguish autonomous world or not. And the biggest reasons are the biggest properties for to become autonomous world are composability and interoperability. I think that's because we are trying to build a new world and a new experience, try to create a new experience that is not existed before blockchain. So the biggest properties for blockchain is composability and interoperability, I think. So that's why we prioritize, we put high value on composability and interoperability. And also there are some properties except for this, like permissionlessness and immutability, and autonomy and wildness and persistence. I think our pre-launching poker game is not autonomous world. That's because pre-launching poker has no wildness. So there is no narrative to be world. And also pre-launching poker game is a session-based game. So there is no persistence. Also, to build our free-engine game and autonomous war, we use our ECS model. So the ECS model means our entity component system pattern for programming. Those are which is based on Cairo on Starknet and the MAD on MAD of Solidity. Both are framework that utilize our ECS model. So entity represents ID of the object, and components stores our data and fetches to the entity. And system executes logics and which treats only components. This is our point. And the benefits of ECS model is here. So ECS model can solve the problems of maintainability and composability and durability, especially when builders want to add new function to the world. They can do that simply by deploying new scripts. So thanks to ECS model, we can get our composability. Then so let's go to the easiest way to build free-on-chain games. But so building our game itself is really hard, but building free-on-chain is more tough. So to build free-on-chain games, builders have to work on a lot of things, not only for smart contracts, which to treat game logics, we have to write tons of TypeScript for front end, and we have to integrate front end and the back end, and we have to set up environments, and we have to deploy and blah blah blah. So Kushaba, who is building Skystorage, which is a free-engine game, he treats like this. So we anyway building free-on-chain game is really tough. So for most talented teams, at least it takes 2 or 3 months to build. So to solve this problem, we divide free-on-chain games to layers. We stop building a free-on-chain game as a one module. We divide free-on-chain games to several layers. So we have our front-end layer and application layer and core layers. So if we do so, if we got our high composability of our board, and if we want to build a new application or new free-on-chain game, you can just focus on this section. So you do not need to build a free-on-chain front-end things and the core layer things. So this is a paradigm shift to build free-on-chain games. Before doing this, we had to build a free-on-chain game. You had to do environment setup, backend development, front-end development, and integrate them and deployment. But thanks to these layer modules, what we should do is our environment setup and the smart contract development. That is only for game logics and lastly deployment. So that's why we are building a PixeLAW. So what is PixeLAW? PixeLAW is a free-on-chain pixel-based platform. People can build various applications on pixels. So for players can select the game mode or pixel. Then if you click this icon, you can play paint game on pixel. So we have several games on pixel, and the front end is like this. So we have currently we have paint game, rock paper scissors game, snake game, treasure hunt game, and Minesweeper and tic-tac-toe against our AI agent on 2048. All of these games are free on chain. So let me talk about the architecture of PixeLAW core. So we use our ECS system, and we use pixels as entities. Each pixel has several components like our X and Y and owner and cars and S. And we have update pixels to treat these components. By calling update pixel function, we can interact with pixels. If you want to build a new application, you need to call update pixel system, so you don't need to care about how update pixel function is working and how about the coordinates of pixels. You just call update pixels if you want to build a new free engine game on PixeLAW. So core components are like this. So pixels components are coordinates and color to represent color in front end, and the owner of the pixel and the application name of the pixels. And the text can be used for emoji to show emoji on front end. There's a timestamp and the action. Action can be used to take our action for users. So if you click move action pixel, there might be happens or movement can happen of the pixels. Let me talk about this later. So also we have several core systems like basically we provide how to register and update your application and update pixel functions. So as I said, to build a new free engine game in your smart contract, you just call update pixel function. So let me talk about how to build 2048 game on PixeLAW. As I said, there are 3 steps: so environment setup, and writing smart contracts, then deploy the application. So environment setup is really easy. So you just GitHub clone up template repository and Docker compose up the. Then, so to build 2048 game, basically you have to implement 2 functions to build our free engine game on PixeLAW. So init function and interact function. Init function is a function to register your application and control permissions for interactions between applications. Also, and the interact function is called by front-end default to process each actions and interact with the core. So what you should do is you write the code in interact function. The inside of interact function, if your game is not initialized, you have to call init game and move direction code function, and there are some helper functions. So to implement init function or to register your application to Pixel core, you just call update application function provided by Pixel core. App manifest can be used to tell your applications, components, and system to Pixel core. And also, then interact function is like this. So interaction function is coded for each actions by front ends. So initialize pixel if the game is not started. So to distinguish our initialized pixels or not, you can read the pixel action properties. Then to initialize your game, you just declare the ownership of pixels and create action buttons by updating pixels. So if you want to have action buttons like this on Pixel, you just what you should do is just update pixels, and you just what you should do is update color and application name, and basically the text can be used to show emoji like arrow, and action can be used to represent to tell actions of that pixels. If initialization of the game is done, app execute action following the command. So if you click move left button, the interactive action called move left function. So move actions can be implemented like this. So firstly, you will read the current status and set local values and write game logics or 2048 game, then which can be used to execute actions for local values. Then, so local values is updated, and after that, what you should do is just call pixel update function for each pixels. Also, as our for 2048 game, if status change, the game creates new number randomly. That's all for deploying writing smart contract parts. So to deploy 2048 game to Pixel, you can use Sozo command, basically. Sozo command is provided by Dojo environment, and Sozo build to build your contract, and Sozo migrate to deploy your contracts. And also you can initialize your contract by online and uploading your manifest to tell your components to tell your applications, components, and systems. I think that's very easy, and you can do whole things in 1 hour or so, and you are getting used to. So as a result, we can play a 2048 game on Pixel. The interesting point is if you deploy your game to the Pixel, Pixel core and Pixel team cannot stop your deployment. So it's a permissionless composability of our worlds. And also building on Pixel is very, very easy. So what you should do is just initialize your application and call update Pixel functions. Also, we have some other features like queue systems, permission systems, and ML agent on Pixel. So for queue systems, which enable the building scheduled applications like such as Snake game and Conway's Game of Life. Thanks to these systems, the pixel can move around the pixel ground. But if pixel moves, also when we play 2048 game, the Snake or Conway's Game of Life pixel can come in our game fields. So the collision might happen. To treat the collision, we have also permission systems, which can specify permissions for interoperability with other games. So your game can select whether your game will interact with other applications like Snake game or Conway's Game of Life or not. Also, we can implement ML agent on Pixel, so you can battle with ML agent by using Geyser. So as a summary, let me talk about the benefits of this architecture. So we divided free launching game to several layers, like front end and application layers and the core layers. So to build a free launching game, you just what you should do is just focus on game logics. The core layer has pixel update functions and the pixel entities and pixel components. So you just call pixel update function to build our free engine games. So this is really easy to build free engine games. So there is no need to build core systems and front ends. You can build a new free engine game in 30 minutes for a very easy application. Also, permissionless but stable. So that means each application can only update pixels to treat pixel states. So we have tightened the diegetic boundaries for our digital multi-user world. So we allow permissionless composability, but we have stable world. Also, there is some teams who is building a free engine game or autonomous world like our like that methods. So Playment team has a rich front end, also rich front end, but the user can build their own application on their Playment teams or world. So they can use front end and core logics to create their own new application free engine game. So this is the links for Pixel and my articles. So that's all. Thanks for listening.
Does anyone have questions for Shora?
So the PixeLAW is built on autonomous world, the MUD framework, right?
Sorry, MUD?
MUD.
MUD is a framework. So we are building a dojo, building on dojo.
Oh, okay. So so if I'm trying to build a let's say snake game, and the other one is trying to build a 2048 game, why we have to share the same core layer? Like why would I want to modify your pixel?
So your question means why all of the games have the same states? Is it correct?
Yes, yeah.
Yeah, it's interesting point. But basically, our purpose is building autonomous world. It's not, in my opinion, it's not a single free engine games. So we provide just a world, and it can be regarded as a kind of metaverse thing and a platform. So, and we give high composability because so we give a high composability of our worlds. So as a result, we have a lot of people can build various applications on our world, and we believe that we will have a new experience by doing that. So I think the interaction between games is not we could not enjoy interaction between our games before blockchain, right? So we just explore the new experience by using blockchain. Does this make sense?
Cool. Another quick question. So if I want to build, like your example is build on the snake game or 2048, can I build something more like a bit more modern games, like maybe like the farming game on Facebook with social features?
Yeah, I think so. Theoretically, you can build anything. So you can, uh, so you can just treat the numerical values. It's not. We call it as a color, but you can interpret the numerical values as other information. So you can theoretically build anything.
Awesome. Thank you.
Thanks so much.
Okay, so if you have more questions, please feel free to come to Shora after the talk, okay? So, and thank you so much, Shora. Thank you.